Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the addition of ammonia derivative or addition elimination reaction. How many ammonia reagents are there, how they react, what type of the product they form, why it is called as a derivative, and why they are very sensitive to pH. The answer of these questions we already discussed in our previous lectures. What we are going to learn today we are going to learn about Canizaro's reaction. First of all, what do you mean by Canizaro's reaction? Canizaro is a scientist name. He first time discovered that reaction, and that's why name is given to that reaction is known as Canizaro's reaction. What are the essential condition or the requirement for the Canizaro's reaction? Here, first criteria for Canizaro's reaction, the carbonyl compound, there must be a carbonyl compound, and as we know that carbonyl compound means particularly in this chapter, because the name of this chapter is a reaction of unsaturated hydrocarbons and the carbon oxygen double bond. We are talking about the carbonyl group which is a polar in nature, and therefore remember here carbonyl group there is no alpha hydrogen atom. Remember first criteria for Canizaro's reaction, no alpha hydrogen atom adjacent to the carbonyl group, right? So no alpha hydrogen atom, what does it mean? We will see shortly. So first criteria, no hydrogen, no alpha hydrogens, no alpha hydrogen atoms, then and then the reaction takes place. That is called as a first criteria. Now second criteria, strong alkali is used here. Strong alkali means basic medium nearly as a 50% of sodium hydroxide or potassium hydroxide is used for this reaction. That is a condition number 2 or criteria number 2. And third one, that is a self oxidation reduction takes place by fourth one, there is a transfer of H minus. Transfer of H minus means we know that hydride, there is a transfer of hydride ion. These are the essential criteria. Only 3 criteria you must remember, and in addition to that you remember there is a transfer of hydride ion. We know that H plus means proton, H minus means what? Hydride ion. This is called as a hydride. Remember this one is a hydride, right? Hydride is here, and therefore we are knowing that. So these are the 3 criteria required for Canizaro's reaction. Number 1, no alpha hydrogen and strong alkali, and no alpha hydrogen atom means what? What are the compound? They do not have a alpha hydrogen atom. Let us see here. Suppose here formaldehyde, we know that C double bond OH. The name of this compound is a formaldehyde. Does this formaldehyde have alpha hydrogen atom, or there is no alpha hydrogen atom? What do you think? This is the carbonyl group. That carbonyl group, the adjacent carbon atom, as we know that, suppose we have this one. Let us see first one, CH2, then C double bond O, here CH2, 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 this type. Now whatever carbonyl groups are there, so this carbonyl group you leave it. This carbonyl group you leave it, and adjacent carbon atom is termed as alpha. Understood this? The adjacent carbon atom after the carbonyl, this is a carbonyl compound, don't count carbonyl compound, don't count the carbonyl carbon, so you leave it, an adjacent carbon atom that is known as alpha. And here look at, this is also as adjacent to the carbonyl group, and therefore it is also referred as alpha. Look at here this carbon atom, and this is referred as a beta. Look at this side, this is adjacent alpha, this one is a beta, this one is a beta, and further this is called as a gamma, delta, omega, and so on. This type of the thing you have to remember. Now look at, this is a carbonyl group, and this carbonyl, after leaving that, there is no adjacent carbon atom, there is a, and therefore there is a no question. Don't count, these hydrogen atom are directly attached to carbonyl group. It is not referred as a alpha. Most of the students get confused. They are counting as these are the alpha. Now let us look at here CH3, C double bond O and H, right? Formaldehyde undergoes Canizaro's reaction because formaldehyde do not containing as alpha hydrogen atom, and therefore it undergoes as a Canizaro's reaction. Two mark question may appear in the exam. Formaldehyde undergoes as a Canizaro's reaction. At that time you have to show as a Canizaro's reaction. And there sometime it may appear acetaldehyde do not undergoes or do not shows Canizaro's reaction, or acetaldehyde do not undergoes Canizaro's reaction. Why? The reason behind it, look at, this is a carbonyl group, right? And this side there is no carbon atom, but this side, look at, this is a carbon atom adjacent to this carbonyl. It is referred as alpha. This carbon atom bearing 3 hydrogen atom, and therefore it do not undergoes Canizaro's reaction. Remember this one. And therefore this another one, suppose as a benzaldehyde. Let me tell you another example here. This one, C double bond O, here is a H. Can benzaldehyde undergoes Canizaro's reaction, or do benzaldehyde show Canizaro's reaction? Yes. Canizaro's benzaldehyde undergoes Canizaro's reaction because benzaldehyde does not have alpha hydrogen atom. There is no alpha hydrogen atom. Adjacent carbon atom is there, no doubt about it. But this carbon atom has a 4 bond, 1, 2, 3 and 4. Therefore no alpha hydrogen atom at the adjacent carbon atom, and therefore it do not undergoes as a, it undergoes as a Canizaro's reaction because there is a no alpha hydrogen atom. Here also has a no alpha hydrogen atom, right? Now let us see another example. Suppose, let me tell you, see this one, C double bond O, CH3. Does this acetophenone undergoes Canizaro's reaction? No. Why? Because look at here, this is a carbonyl group. This carbonyl group, you go this side, there is a alpha carbon atom, but this alpha carbon atom does not have a alpha hydrogen atom because 4 bond already there, 1, 2, 3, 4. And now but you go this side, this is also as a alpha carbon atom, but this alpha carbon atom carrying as a 3 hydrogen atom, and therefore there will be a no Canizaro's reaction. It does not undergo Canizaro's reaction. Understood this one? So acetophenone does not undergo as a Canizaro's reaction. Now let me give another one example here. CH3, then here CH3, another one CH3, C double bond O, and this one H. Does this molecule, whatever it may be, we don't know the RUHC, but it is a aldehyde. Does this molecule undergoes Canizaro's reaction? What do you think? Look at here, this is a carbonyl group, right? Let me give the RUHC name of this compound. 1, 2, 3. At 2 position there will be a methyl group. Therefore, there are the 2 methyl groups, and therefore di. So dimethyl, right? Dimethyl. So 2,2-dimethyl, 3 carbon atom in the straight chain, and therefore propane, and the aldehyde group is there, therefore last suffix must be Al. This is the correct IUPAC name of this compound, 2,2-dimethyl propanol. Does this 2,2-dimethyl propanol undergoes Canizaro's reaction? No, it does not undergo. So yes, it undergoes as a Canizaro's reaction. Why? Because there is no alpha hydrogen atom. This is a carbonyl group. This side there is no carbon atom, but this side there is a carbon atom, right? But these carbon atom do not have alpha hydrogen. Here is a methyl group. Here also is a methyl group. No alpha hydrogen, and therefore this compound can show Canizaro's reaction. Understood? These are the criteria, introductory part for Canizaro's reaction. Now let us see, there are 3 types of the Canizaro's reactions are possible. What are those? First one is called as a simple Canizaro's reaction. Second one is called as a crossed Canizaro's reaction. And third one is known as a intramolecular Canizaro's reaction. Remember, there are 3 kind of the Canizaro's reactions are taking place. Number 1 is a simple Canizaro's reaction. Simple Canizaro's reaction. Simple Canizaro's reaction. And what does it mean? Simple Canizaro's reaction means what? For Canizaro's reaction, for condensation of the reaction, for this reaction required 2 molecules are there, right? And therefore, if the same molecule undergoes self-oxidation reduction reaction, both molecule should not, because same molecule like as a formaldehyde with another molecule of formaldehyde, one will show as a oxidized form, another one is a reduced form. And here also as a one important point you should remember, and here also the formaldehyde, it goes as a oxidase, but in a simple there is no what we can call it as a distinct point between these, because both are the same molecule. So if both molecule, one will go, one undergoes as a one undergoes as the oxidized form, another should go the reduced form. There is no difference between these two. But when we are going to talk about the crossed Canizaro's, remember crossed means the 2 different molecule shows as a oxidation and reduction. That type of the reaction is called as a crossed Canizaro's reaction. And intramolecular Canizaro's reaction means what? The reaction takes place within the molecule. That type of the reaction is called as the intramolecular Canizaro's reaction. Let us see one by one over here. The simple Canizaro's reaction. Now I am writing here the 2 moles of HC double bond OH, that will be treated with 50% of sodium hydroxide. And what does it give? It will give the product HC double bond O. Here is a Na plus minus charge and plus CH3OH. One is a one form as a sodium salt of the formate ion, and one this is called as this is a oxidation form. Oxidation, and this is a reduced form, that is a reduction, right? Self oxidation reduction, one undergoes as a oxidation, another one goes as a reduced form. How this takes place, let us see here. Look at the mechanism, and as we know that mechanism is a language of the organic compound, and if you know the mechanism, you can easily predict the product. Why I am predicting this product? Because I am knowing the mechanism behind it, and that's why I am predicting that one. Now you can able to predict that one if you know the mechanism. Now let us see the mechanism here, how it takes place. Here one C double bond OH here, that will be treated with OH minus. OH minus, where from that OH is coming? That OH is coming from the base OH, and now it is going to attack over there. Negative charge will be over there, H, then CO minus, H is there. This is a step number, you can call it as a step number first over here. Now OH, right? This is a oxalate type of the thing we are getting in the first. And first step is a very step number first, that is the step number second over there. Now this one H, then CO minus, then here you can write H, then there will be a OH. Now another molecule of this acetaldehyde, formaldehyde, this is called as a formaldehyde. Now C double bond O, and this is a H. Now what is going to happen? The negative charge coming here, and this hydrogen atom transferred, hydride transfer. Hydride transfer means what? When this hydrogen goes from here to here, and as we know that bond is nothing but as a sharing of that electron, and when it goes, it takes both the electron along with that, and therefore this is called as a hydride transfer. And when you are going to get here this one H, then C double bond O here, then I am writing this here OH is there, OH, and plus here is a H, C, O minus this H, and one H is coming from here, right? And there is a fast exchange of proton. This proton is a highly acidic in nature, and therefore this will pick up the proton from here, and you are going to get the product is this one H, C double bond O, O minus, and that sodium is already present over there. It comes here, plus you can write here, and this one, these three, here 1, 2, 3, you can write CS3 and one OH. This is the sodium salt of formate acid. This is called as a sodium formate. Name of this compound is the sodium formate, and as we know that name of this compound is a methanol, right? Methanol. And once you know the mechanism, you can now understood the mechanism, how the mechanism takes place over there. This is one of the best example for the simple Canizaro's reaction. Now you predict the product here. Let me give another example to you. Now let us see here, one is a benzaldehyde. As we know that benzaldehyde undergoes undergoes Canizaro's reaction, sodium hydroxide. Predict the product. What do you get? And predict the product. Two products you are going to get. One is a oxidized form. Among these, which one is a oxidized form? This one is a oxidation, and this one is a reduction, right? Reduction form, remember. And now here, after predicting, you are going to get the product. Let me show here. Then O double bond O, then O minus, sodium plus, and another one maybe as a this one, right? CH2OH. This one is a sodium salt of sodium benzoate. This is called as a sodium benzoate, and this is called as a benzyl alcohol, right? So in this way we are getting as a formation of the product. Understood this one? Here in the workup, the benzoic acid also obtained over there. If you use as a water, you will get as a this one, right? Back. So this is the second example of the simple Canizaro's reaction. Let us see another reaction. Second one, suppose you have this one. You just predict it. CS3, here is a CS3, C double bond O and H. There are two molecules of, because they are the simple Canizaro's reaction, means same two molecule. One molecule undergoes as oxidation, another one goes in this is the oxidized form, oxidation, and this will be the reduction form, and we are getting as a formation of the product. Here again strong alkali used, nearly as a 50% sodium hydroxide and or potassium hydroxide. What you are going to get? Same, instead of pH you can show as this group, that's it. So here you can write CS3, then CH3, CH3, C double bond O, Na, here is a plus minus charges over there, and another one you will get, there is no ring, but here there is a tertiary group, this one, CH3, then CH3, CH3, then CH2 and the OH. This is the alcohol group we are going to get. Can you tell me the IUPAC name of this compound? This one, 1,2,3, 2,2-dimethyl propanol. Here 1, 2, 3, that is a 2,2-dimethyl propanol. That will be the IUPAC name of this compound. So in this way we have seen as a simple Canizaro's reaction. Now let us look at the another reaction. In the another reaction which is known as a crossed Canizaro's reaction. Second one is known as a crossed Canizaro's reaction. Look at here, crossed. Cross means hybrid type of the, you might be in the botany you are learning that one. Crossed. So similarly in the chemistry, cross Canizaro's reaction means two different molecules, but that both the molecules should not have a alpha hydrogen atom. Then and then they will show the crossed Canizaro's reaction. Remember, one is a formaldehyde, another one is a benzaldehyde. Let us see here, H, C double bond OH. This is one of the compound, and another different compound is this one, right? This one, formaldehyde. As we know that there is no alpha hydrogen atom in a formaldehyde, in the formaldehyde, as well as benzaldehyde also no alpha hydrogen. This is a benzaldehyde. Both do not containing as a, and there, but they are two molecules, both are the different, and therefore they undergoes as a Canizaro's reaction. And what the product you are going to get? Here you are going to get C double bond O, Na plus minus, and another one is a benzyl alcohol, CH2OH. Remember this type of the product. And here remember, at the beginning, just now I already told you that when cross Canizaro's reactions are there is a competition which molecule should go the oxidized form and which molecule should go the reduced form. Here the formaldehyde, it is most oxidizable, and therefore it first undergoes as a oxidized form, and benzaldehyde undergoes as a reduced form. So this is the important point you should remember while predicting as a product. This one is a sodium formate and this one is a benzyl alcohol, as we know that. Or the IUPAC name of this compound is 1-phenyl methanol, you can call it. Right? Now let us look at as a mechanism here. Mechanism similar to as a simple, we are going to see here. What is going to happen here? Let us see here, formaldehyde C double bond OH, that will be treated with OH minus, and where from that OH minus is coming? It is coming from the 50% sodium hydroxide, the base which we are employing in the reaction. So OH is coming from that side, and this is going to attack on this carbonyl group, and we are going to get here HCO minus, this CH and OH which is coming from that one. And now this is a step number first, right? This is a step number first. And now look at the step number second. Step number second, you write down this molecule as it is. Observe this molecule carefully, OH, and then benzaldehyde, as we know that benzaldehyde C double bond OH, right? Now this negative charge forming as a double bond with that oxygen. Now this hydrogen atom, this hydride transferred from here to here, right? When it is a transferring, how the products are formed? H, then C double bond O. I am writing this OH over here, and now here plus this one benzaldehyde, then CO minus here 1H, and 1H is coming from here, right? This H I am writing over there. And this alkoxide is a very basic in nature, and this acid is a very highly acidic in nature. Therefore, there is a fast exchange of proton. This will pick up the proton easily, and we are getting here HC double bond O, ONA plus minus charge, and finally we are getting here pH, then CH2OH. Understood this one? How these products are coming? Sodium formate, this is the oxidized form, oxidation reaction, and this is a reduced form, reduction reaction, right? This goes in the oxidized form, that goes in the reduced form. There is a competition. So this type of the reaction is called as a cross Canizaro reaction. There should be a no alpha hydrogen atom. It undergoes as a self oxidation reaction, and strong alkali is employed in the reaction, and there is a transfer of hydride ion. These are the point you should remember while, because in an exam, what kind of the question, the nature of the question is like this: write notes on Canizaro's reaction, or explain the Canizaro's reaction with suitable with a suitable example, or sometime why acetaldehyde do not undergoes Canizaro's reaction, or does not undergoes Canizaro's reaction. So that type of the question may appear here. Now let us look at as a third one. Third one, as we know that third one, which is a intramolecular Canizaro's reaction. Now third one is known as a intramolecular Canizaro's reaction. Third one is a intramolecular Canizaro's reaction. And intramolecular, here is the same criteria again: no alpha hydrogen atom, then self oxidation reduction, and third one, what is that? Strong alkali is used, right? These are the three criteria. But here intramolecular, this word itself suggests that the reaction going to take place within the molecule with the same molecule, and at one position they goes in oxidized form, in the second one is a reduced form. Let us see how it takes place. For example, suppose we have this one, C double bond O, then C double bond OH. This is a one of the carbonyl compound, right? This is a alpha, right? But this is a adjacent. There is a no alpha hydrogen atoms are there. This is a aldehyde because they are directly attached to this. This carbonyl group has a adjacent. Most of you might be thinking that this may be as alpha hydrogen. Don't consider that. This is a aldehydic group. This one. This is aldehydic group. This is also as a aldehydic group. Don't consider. Or some of the students may think that why not this carbon has a alpha hydrogen. This carbonyl, the adjacent carbon is this one alpha. This is alpha, and this alpha has a one alpha, and therefore how come that intramolecular Canizaro's reaction? No, this you separately consider. This is the aldehyde or the formyl group. This is also as a formyl group, and that will be treated with 50% NaOH, and you are going to get here one this like this. Here may be NaO minus C double bond O and CH2OH. This type of the compound you are going to get in this case. How it comes? Let us see the mechanism here. The name of this compound is, I think, intramolecular, that is a glyoxal. This one is called as a glyoxal. Al indicate as a aldehyde group. The common name of this compound is a glyoxal or the ethane 1,2-diol. This is known as ethane 1,2-diol. Here ethane, because 2 there, therefore 1,2-di-Al. Al indicate as again aldehyde groups are present. The name of this compound is a glyoxal or the ethane 1,2-diol. And now how the mechanism takes place here? H C double bond O, C double bond O, H, and then OH minus attacking this side. It doesn't matter. So here we are going to H, then CO minus, Now here is a OH and this C double bond OH. Understood this one? Now in the same reaction, what is going to happen? This negative charge comes here and this hydride transfer from here to here, and you are going to get here C C double bond OH, then CO minus H. This and one H is coming from this. This acidic is a highly acidic in nature. This is a basic in nature. This transfer from this to this, and you are going to get here this Na O minus C double bond O, then COH, H, and the H means CH2OH, like this. So I think with this we have covered all these intramolecular reaction, and in the next lecture we will see the RUHC reaction. Let us stop today here. Thank you. Have a nice day.